Have you ever used an app that just feels perfect? Where it's not just fast, it's almost like it's reading your mind.
Oh, absolutely. It's that feeling where you tap something and the result is already there. It's not loading, it just appears.
Exactly.
Yeah.
It feels effortless, like the software knows what you want before you even do.
Well, that seamless experience is it's one of the hardest things to engineer. Underneath that really smooth surface, there's just an incredible amount of complexity. It's less like an app and more like a tiny self-managing city running in the background.
And that city management is what we're doing a deep dive on today.
Uh-huh.
We're pulling back the curtain on Sunmax LLC's in-app automation mechanisms.
Right. This is the silent workforce that keeps the whole system running. And we're not talking about, simple scheduled tasks. This is about prediction and acceleration.
And our mission, really, is to get past the buzzwords. We want to understand how it's not just automating, but it's context-aware. It reacts to how you are using the app right now.
That's the key. The aha moment is realizing how dozens of these tiny micro-automations are working together, almost like a synchronized machine, to make everything smooth.
Okay, so let's start with the foundation. You mentioned there's an architecture here, and it rests on what you called 3 pillars.
Yeah, 3 foundational pillars, and it's how they work together, how they coordinate their timing. That's really the magic here.
The core of the system's stability.
Exactly. One pillar is sort of looking to the future, another is managing the present, and the third is watching the environment. It's a whole system.
Let's take the first one then, the Predictive Execution Engine. This sounds like the part that gives it that psychic feel.
It is. The engine is basically a really sophisticated observer. It's constantly analyzing your behavior, what features you use, the sequence you tap them in, how long you stay on a screen.
And the goal is to get the next action ready before you even trigger it.
Precisely.
So, okay, let's use an example. I open the Tools panel, and say 9 times out of 10, I immediately go to check my Sunmax Gold.
The engine sees that high probability, and it acts. It starts what we call a shadow load. It begins loading the gold module in the background while you're still looking at the Tools panel.
So it's already working ahead of me. But what about resources? Doesn't that prediction, eat up my battery?
That's the critical part. It only commits the bare minimum. It preloads data structures, maybe some UI components, but it holds off on the full rendering until the very last moment.
Okay, but let me push on that. What if the engine is wrong? I go to settings instead of gold. All that work has to be thrown away, right? Doesn't cleaning that up cost more than you gain?
That is the core challenge this thing solves. The genius isn't just the prediction, it's how it manages the cost of being wrong. The resources it allocates are extremely lightweight and temporary.
So if the prediction fails?
It just drops them.
Yeah.
Instantly. The cost of cleaning up is tiny compared to the milliseconds of perceived speed you gain when it's right. It's optimizing for your habits.
Got it. Optimize for the 80% case, but make sure the 20% exceptions don't create a drag. That makes a lot of sense.
Right.
So that leads us to pillar 2. The autoflow task runners.
Right. If the predictive engine is about the future, these are all about the now. They're the bedrock of stability.
And they're running constantly.
Constantly, every few milliseconds. They aren't waiting for you to do anything. Their job is just system hygiene, data integrity.
So what are they doing specifically?
The essentials.
Yeah.
Refreshing critical data, making sure the UI state is perfectly in sync, updating currency rates, and really importantly, they trigger performance cleanups. They're the maintenance crew that never stops working.
Okay, and that brings us to the third pillar, the smart trigger conditions. This sounds like it deals with everything outside the app, the real world.
Yes, the chaos of the device itself. This is so critical for mobile apps. The smart triggers are detecting context like your network quality, if the device is getting hot, if there's a sudden spike in memory usage.
So it's not just built for a perfect scenario. It knows how to degrade gracefully.
Precisely. Let's say your phone starts heating up. Maybe you've got another heavy app running. The smart trigger detects that and automatically throttles things back.
Yeah.
It'll reduce the frame rate on some non-essential animations, maybe lower the graphics quality just a tiny bit. It's choosing stability over visual flair when the device is under stress.
But how fast can it react? I mean, isn't all that constant monitoring creating its own lag?
It's designed to be incredibly low overhead. It uses low-level system hooks, so it's not polling constantly, and the reaction is almost instantaneous. It has to be.
So a memory spike gets detected, and the response happens.
Within tens of milliseconds. The goal is to fix the problem before you, the user, ever feel a performance drop.
That's amazing.
Yeah.
And that ability to react to the hardware, that feels like the first step to making the experience personal. Which leads us to the next big topic.
Mhm.
How the app optimizes itself just for you. We're talking about behavior link automation.
Behavior link is where it gets really intelligent. It's not just predicting your next tap. It's building a persistent optimization map just for you. It learns your unique flow.
So it's tracking my entire journey through the app.
Hmm.
What I open first thing in the morning, which tool I use late at night.
Yes, and crucially, which screens you always skip.
The skipping is key.
It's so key because if you always go from step 1 to 3 to 5, the system learns to just short-circuit steps 2 and 4 for you. It essentially builds a custom path through the app that's optimized for your exact usage pattern.
Okay, but doesn't that create a risk of overfitting? Like, what if my habits change? I start using a new feature that breaks my old flow. Does the app suddenly feel sluggish because it's stuck on my old personalized path?
That is a fantastic question. And yes, overfitting is a real danger. The way Sunmax handles it is with a weighted decay function on all that habit data. Meaning, your most recent activity is weighted much more heavily. If you start deviating from your old path, the system doesn't just abandon it, it's sort of. It deprioritizes those old micro-automations temporarily. It learns to adapt with you.
It's built for adaptation, not just speed. That's fascinating. Okay, so we've covered the big picture. Now let's get into the engine room. How does all this high-frequency work get done without grinding the phone to a halt? Let's talk about the micro-automation threads.
Right. So if the autoflow runners are the big maintenance team, these are the tiny laser-focused specialists. Think of them like 200 little engineers, and each one has only one very specific job to do.
An atomic action, you called it. Give me some examples.
Okay, so one might just be in charge of validating your user token. Another one might be refreshing a tiny part of a live chart, not the whole thing. And a really important one is cleaning up unused event listeners.
Whoa, hang on. Unused event listeners. What are those, and why is cleaning them so critical?
Okay, so an event listener is basically a bit of code that's just sitting in memory, waiting for something to happen. A click, a data update, whatever.
Right.
If you navigate away from a screen and that listener isn't properly destroyed, it just stays there. It's a memory leak. Think of them like sticky notes you forget to throw away. Eventually, the whole desk is covered and you can't work.
And the app feels heavy and slow.
Exactly. The microthreads are constantly going through and purging that debt. It's why the app feels just as fast after 3 hours of use as it does in the first 3 minutes.
That explains so much. Now, tied into this is something called AutoSync. You described it as the heartbeat of the system.
It really is. It's this quiet, constant pulse, and its whole philosophy is minimal bandwidth, maximum integrity. It never, ever blocks the user experience.
So what are its main jobs? What's it syncing without killing my data plan?
It handles the universal stuff. Currency rates, good prices, verifying your user data is still secure. It sends these little handshake pulses to the cloud. And it also does something called module version matching.
Module version matching.
Yeah, the app is built in modules, right? So different parts can be updated separately. AutoSync is just making sure all the modules on your device are the correct version without you ever having to do a full app update. So that keeps the whole ecosystem consistent.
So we've got speed, we've got personalization, and we've got synchronization. But what happens when something breaks? Because software always breaks. There are always glitches. We have to talk about self-healing automation.
The true sign of a mature system isn't that it never fails, it's how quickly it recovers. The self-healing mechanism is like an internal diagnostic tool, always looking for signs of distress.
And it's looking for more than just a crash, right?
Oh, way more. It's looking for subtle things. A button that doesn't respond. A small but persistent memory leak. A data bridge that's become corrupted. It's diagnosing the fault in real time.
And once it finds a problem, what does it do? How does it repair itself without just crashing the app?
It has a layered response. For small issues, it just reloads what's called a mini handler, a tiny block of logic for one specific interaction. It just restarts that one little piece.
Then for bigger problems, like corrupted data.
Then it moves up a level. It might reset an entire module, rebuilding its state from a clean backup. And critically, it can recalibrate what are called bridge code routes.
Okay, you have to give me an analogy for bridge code routes. That sounds important.
Think of them like the data highways inside the app. They control how info moves between the tools panel and the gold module, for instance.
And if there's a traffic jam on one of those highways?
The self-healing automation instantly detects it and reroutes the data. It finds a detour and implements it before you even notice the main road was blocked. The app just keeps working.
So it's correcting its own logic faster than a human could even perceive the glitch.
That's the goal. It creates this this self-maintaining digital organism. It's why automation isn't just a feature in Sunmax, it's literally the DNA of the architecture.
It is. So, to recap for everyone, these in-app automation mechanisms give us 5 core benefits. The Sunmax app is fast, it's stable, it is intelligent, it's personalized, and maybe most importantly, it's self-repairing.
And that entire stack underpins everything else. It enables the multi-currency engine, it stabilizes Sunmax Gold, it optimizes the tools panel, it's connected to Link Protocol, Rapid Flow, the entire App 3.2 architecture. It's what makes it all work.
It's an endless loop of optimization and repair. Which brings us to our final thought for this deep dive. We want to leave you with something to really think about.
Right. So if the goal of this kind of tech is to correct its own errors and predict your next move before you even know you're going to make it, how does that change your relationship with the technology you use every single day?
When software works as perfectly, it becomes invisible, doesn't it?
Yeah.
It just feels like an extension of your own thoughts. So think about that balance, the invisibility of perfect function and the deep, deep personalization that makes it possible. What happens when the app actually knows your habits better than you do?